Assalamu alaikum everyone. So this right here is one of the very first in the series of videos where we are going to discuss the O-levels chemistry course. I'm going to make sure that these videos are detailed and I'm going to try and cover as many topics as possible in the next month and a half so that you can prepare well for your midterm exams. Okay, so let's start with the very first topic, which is the structure of an atom. So what's inside an atom? Inside an atom you have a nucleus. All right, a nucleus is made up of neutrons and protons, and essentially what you have is you have the protons, these red ones, which are positively charged, and then you have the blue ones, which are the neutrons. Now I'm writing the neutrons or labeling the neutrons with an N, not with any charge. Why? Because neutrons are neutral, they do not carry any charge. Then we have these smaller particles, these electrons, which are moving around in an orbit around the nucleus, not inside the nucleus, outside the nucleus. The orbits are not inside the nucleus, all right, and these are known as electrons. So protons, positively charged particles; neutrons, neutral particles, do not carry any charge. Protons and neutrons are inside the nucleus. Then outside the nucleus we have small negatively charged electrons that are orbiting the nucleus. All right, let's talk about these particles in a bit more detail. Like we discussed, protons are in the nucleus and have a positively charged and they are a positively charged particle. So the mass of a proton is what? The mass of a proton is 1 atomic mass unit. All right, we are going to discuss what is 1 atomic mass units in a second. Neutron, again inside the nucleus, does not carry any charge, again has a mass of 1 atomic mass unit. Electrons, they are in the orbit, carry negative charge, and like I said, they are smaller compared to protons and neutrons. They are exactly 1840 times less in mass compared to your protons and your neutrons. Okay, so the mass is 1 upon 1840 atomic mass units. Okay, so very simple. You have nucleus in the center, protons and neutrons in the nucleus, electrons at the orbit. Now why do the electrons orbit? So you have your nucleus over here and the electrons in the orbit. Why? Because the nucleus is positively charged because of the protons, the orbits are negatively charged because of the electrons, and this positive and negative charges attract each other, and this attraction basically leads to the electrons staying in the orbit and not flying away. Now, what is an atomic mass unit? An atomic mass unit is 1/12 the mass of a carbon 12 atom. Now, why are we considering the carbon 12 atom? We are considering the carbon 12 atom. Why? Because it has exactly 6 protons. So 1, 2, 3, 4, 5, and 6. So you've got 6 protons, and then you've got exactly 1, 2, 3, 4, 5, and 6 neutrons. So if we divide it by 12, you get the mass of a single proton or a neutron. And that's why we say that 1/12 the mass of carbon is the mass of a proton or the mass of a neutron. Later in your AS and A2s, you're going to learn that the mass of a neutron is just so much slightly more than the mass of a proton. But as far as our course is concerned, the masses are equal and they are equal to 1 AMU. All right, so the carbon 12 has 6 protons, 6 neutrons, 6 electrons. We discussed that. The mass of an electron is negligible compared to the mass of protons. So we say that it's a carbon 12 atom and we consider the mass to be 12, even though there's 6 protons, 6 neutrons, but then there's 6 electrons as well. But like we are saying that the mass is what? The mass of the electrons is negligible. All right, so they're very, 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 very tiny and small compared to your protons and neutrons, so we can just ignore their masses. Okay, so I hope that this made sense to everyone what 1 AMU is. Now, how do we characterize an atom or an element? Okay, so characterization of atoms and elements takes place by using quantum numbers. What are quantum numbers? The very first quantum number is the proton number. We also like to call it the atomic number. All right, so either the proton number or the atomic number, which is the total number of protons in an atom. Each proton number is unique to an element. All right, so let's say for example you have carbon. Okay, now a carbon has exactly 6 protons. Now an element with more than 6 protons, let's say for example you have 7 protons, it's not carbon anymore, it's nitrogen. An element with less than six protons, let's say for example you have 5 protons, it's no longer carbon, it's boron. You can take or give neutrons, it's the element is, or the atom is going to belong to the same element. You can give and take electrons, the atom is again going to belong to the same element. But if you give or take away protons, which you can't by the way, but still I'm just assuming that if you have more protons or you have less protons, the element changes. This is 7 protons, no longer carbon. This is 5 protons, no longer carbon. Okay, so we have the proton or the atomic number, which tells you the number of protons. It's unique to each element. All right, the atomic number is unique to each element, means no other element other than carbon can have 6 protons. Okay, and then you have atomic mass. Now atomic mass is not common to each atom or each element. Okay, it's the total number of protons and neutrons, total number of protons and neutrons. Okay, and let's take an example. So you have potassium. Potassium has a 19 written and a 39 written. The top left is 19. This right here is the atomic number. All right, or the proton number. And then this right here, the 39, is the atomic mass. So let's put together the number of each type of particle that an atom has. So 19 potassium 39 has 19 protons. Why? Because the atomic number is 19. It has 20 neutrons. Why? We can figure out the number of neutrons by saying that, okay, each nucleus is supposed to have neutrons and protons. Potassium has 39 of them, out of which 19 are supposed to be protons. So how many neutrons are there going to be? We can subtract and say that, okay, there's going to be 20 neutrons. So each potassium has 20 neutrons. Because we assume, characteristically, we assume that each atom is neutral. So if there's 19 protons, there has to be exactly the same number of electrons. So if you have 19 protons, there's supposed to be 19 electrons as well. Okay, let's talk about oxygen. Let's put oxygen over here. So you have 8 and then the oxygen symbol, and then you have the 16. What does that mean? Number of protons is going to be what? Number of protons is going to be 8, because the top left, the number of the atomic number is 8. Then 8 plus the number of neutrons, 16. 8 plus the number of neutrons is 16, the atomic mass. So number of neutrons is going to be 8 as well. The 8 goes over here, subtracts, and you get 8 number of neutrons. And then you want to figure out the number of electrons. So the number of electrons is going to be 8 as well. Again, assuming that your atom is neutral. So this is how you are basically going to figure out how many particles a particular atom has. There are ions as well. And how do ions differ from an atom? We are going to talk about that in a later video. For now, you need to know what's inside an atom, what particles are, what chemical symbols are, and how to figure out the number of particles in each atom. All right, that's it for this video. Inshallah, I'll see you in the next one. Bars out.